The most amazing sights in the cosmos can be found in its light shows, solar and lunar eclipses, and shimmering meteor showers. We are constantly amazed by the natural phenomena that regularly take place in space. While some events can be seen in the night sky quite frequently, other galactic events happen at intervals of several thousand years. For this reason, experts are even more thrilled when they are able to see such a rare phenomenon up close. What an amazing event the experts saw a few weeks ago, and which similar spectacles give the universe its cosmic beauty. This video will tell you whether you're excited about the amazing things in the cosmos. Whether so, you might want to subscribe to our channel to find out more about upcoming unusual interstellar events. If you enjoy our work, please give it a thumbs up. Remarkable meteor shower. A meteor shower is a dazzling natural phenomenon that occurs when comet debris burns up in the Earth's atmosphere. The shorter the time between meteor showers, the easier it is for experts to trace the regularly executed paths. In the past, some galactic paths have emerged tracks on which the corresponding debris preferentially follows orbit. In this way, scientists can also determine the host comet of a meteor shower. However, this task is much more difficult for a meteor stream that occurs only roughly every 4,000 years. In April of this year, experts witnessed a fascinating shooting star shower, the origin of which they were initially unable to identify. Eventually, they were able to identify a certain regularity in a long-period comet, which is the source of this captivating spectacle. In particular, the specialists discovered that the host comet, C2002 Y1 Jules Halverson's orbit around the Sun, takes approximately 3967 years. The combination of rock and ice particles last came to our host star in 2003. Since the detailed study of these long-period missiles proves to be very difficult, experts have only previously identified 5 of these special host bodies whose ejected particles are responsible for the captivating spectacles in our terrestrial night sky. Accordingly, the comet's previous solar detachment can be dated to the period around 2000 BC. This was done as part of a large-scale research project that involved numerous observing stations in various countries. The list of long-period comets that cause recurrent comet showers has lately been greatly increased by experts. To do this, the specialists searched the sky for meteors, which are what we have dubbed shooting stars. Based on their findings, the trajectories of the celestial bodies could be examined and contrasted with the data from a NASA database. However, because this cosmic treasure trove of knowledge includes data from over 10 years, scientists have finally discovered that, in contrast to the previously mentioned comet, whose orbital period around the Sun is close to 4,000 years, at least 9 meteor showers correspond to the trajectories of long-period comets. The rotation times of the other objects under examination are rather brief. In the course of their work, the experts discovered another surprising detail. Meteor showers from long-period comets tend to last several days, while their radiant point of origin in the sky seems to shift further and further away. The first conjectures suggest that this perplexing situation could be attributed to the comet's temporarily altered trajectories, which would mean that the comet's orbits change gradually over time. The majority of the comets under investigation have orbital periods that boil down to 400 to 800 years, but some outliers require more than 1,000 years to orbit the host star of our solar system. Given how spectacular meteor showers are, how do they happen? The question of how this cosmic display is made in the first place emerges, because the corresponding formations burn up in the surrounding gas shell of our home planet before they reach the ground. Meteor showers or streams are often mistakenly referred to as meteorite showers. However, a meteorite is only a solid galactic body that crosses the Earth's atmosphere and eventually hits the surface of our home planet. When our planet crosses a comet's orbit, while it is orbiting the Sun, the comet's intense radiation causes the structure to lose some of its mass over time. The dust and rock fragments that fall off during this process are then dispersed over large portions of the comet's original orbit. If the Earth passes such a cluster of galactic particles while orbiting the Sun, the small particles enter our atmosphere and eventually evaporate because, as previously mentioned, the particles accumulate on the comet's trajectory and the Earth follows a fixed rotation curve around the Sun. The majority of meteor streams that can be seen from Earth exhibit some regularity. To determine a meteor stream's strength, researchers utilize the so-called zenithal hourly rate. This ZHR number shows how many meteors would be spotted in an hour under perfect circumstances. The so-called quadrantids are one of the most active shooting star events that can be regularly observed. They are a recurrent meteor shower that primarily occurs between December 28th and January 12th. The quadrantid's radiant or apparent origin is located in the Bear Keeper constellation. Under ideal circumstances, this phenomenon typically reaches its galactic zenith in the night, between January 3 and January 4. This is only a few hours. Within an hour, there are more than 100 shooting stars visible in the firmament. In certain years, there are over 200 meteors. The meteors travel across the night sky at a pace of 25 miles per second for 60 minutes at this time. Although the existence of this cosmic phenomenon has been known for almost 200 years, the host comet of the quadrantids was unknown for a long time. The quadrantids were first discovered in 1825, when Italian researchers noticed unusually intense meteor showers. When it comes to the question of the origin of the recurring meteor stream, experts believe that the celestial object 2003 EH1, which was discovered at the beginning of the millennium, is the most promising candidate. They believe that it is the inactive remnant of a once significantly larger cometary nucleus, which may have broken apart over the millennia, allowing 2003 EH1 and the quadrantids to develop. The actual origin comet may be C-Horn 90Y1. These presumptions imply comparisons of the orbital components of this celestial object, which Chinese researchers discovered over 500 years ago. In fact, this meteor shower, which peaks annually around December 14th, is regarded as the strongest shooting star event we may witness in the heavens. The word Gemini means twins in Latin, and the Geminids are the only ones that transcend the quadrantids in terms of strength. The origin of the name of the meteor stream comes from the fact that the radiant of the phenomenon is located in the constellation of Gemini, compared to the meteors that burn up in the Earth's atmosphere. During the quadrantid shower, the objects of the Geminids seem much more spectacular. This is mainly due to the fact that this galactic shower produces particularly bright yellow-white formations, while the quadrantids appear relatively dark thanks to the favorable spatial constellation. Between the radiant and the sun, the Geminids can sometimes be seen not only in the hours before dawn, but sometimes during the evening hours too. Especially interesting is the fact that the intensity of the meteor shower has increased in the last few decades. While the maximum zenithal hourly rate of the Geminids was 160 in 2013 and 2014, the corresponding value was 200, only 1 year later, with a ZHR value of 150 and 140. Respectively, the development declined again in the 2 following years. Responsible for this impressive spectacle is the debris ejected from the asteroid 3200 Phaeton. The corresponding original body needs not even 5 years to orbit the Sun completely in the past. Experts believe that 3200 Phaeton could be an inactive comet that has completely lost its volatile dust and gas components. The celestial object had started to disintegrate, which would explain the vast mass of debris regularly entering the Earth's atmosphere. However, a measurement made a few years ago by the stereospace probes demonstrated that 3200 Phaeton show symptoms of frequent matter releases. This so-called outgassing rendered the thesis that the host object was an extinct comet invalid for the time being. In order to get to the bottom of the origin of the Geminids, the Japanese space agency JAXA plans to implement a large-scale project next year. The unmanned spacecraft Destiny Plus will examine the asteroid 3200 Phaeton in detail and provide a definitive answer to the origin question. Now it's your turn. What do you think about the incredible meteor showers that we occasionally marvel at from Earth? Have you ever seen such a phenomenon up close? Please share your thoughts and feedback in the comments section. You should also watch the other fascinating videos that we've included in the credits. We appreciate your significant interest. Be careful and we'll talk to you soon.